So the topic, what's smoking now, Fairbanks air quality and PM2.5. When you're going to discuss this, the first question is, what the heck is PM2.5? It's something you've been hearing in the news. You may not know much about it. So let's start with some definitions, because first and foremost, I happen to be a geek, and I speak geek fluently. And most people don't speak geek the way I do. So I need to give you a frame of reference. So when we talk about an aerosol, it's any solid or liquid that's suspended in a gas. So it could be the atmosphere, it could be your aerosol spray can. So what happens? You've got an aerosol, it's suspended. It's falling out. So one of my favorite examples of an aerosol is a car driving off a cliff. While it is suspended in the air before it hits the ground, is an aerosol. It just has a high settling velocity. So we're not dealing with cars here. We're dealing with particles that are settling, but they're much, much smaller. We're talking on the order of a 50th of a diameter of a human hair. So very, very small particles that are almost naked to your eye. And PM2.5, here's that magic set of words. It is an aerosol, so it's suspended in the atmosphere. It's smaller than 2.5 microns in aerodynamic diameter. What does that mean? It means that it is 2.5 times 10 to the minus 6 meters. It is very, very, very small. We call these respirable particles because they can get into your lungs. You also hear them called fine particles. Coarse particles means you go up to 10 microns in aerodynamic diameter. And this is a very empirical term. This means, what do? You take a vacuum cleaner, you suck everything out of the air that is smaller than 2.5 microns, and that is your PM2.5. Okay, so where does it come from? Natural sources, we all know about these. If you happen to be down by a river and lust is blowing, that's an aerosol. You can get small particles. Wildfires produce nice particles. As everybody here knows, every summer, what do we have? We have a great aerosol episode. Or if we're lucky, we happen to have a very wet summer. Sea salt, volcanoes, all of these things produce aerosols. Gobi Desert dust, Taklamakan Desert dust. We actually see dust from China here in Fairbanks in the spring. Anthropogenic, big word meaning human-caused. So these are things that are results of human activities. Combustion usually, something burning. So vehicle exhaust, you're talking about power plants, smelters, road dust, home heating, which is a big one here in Fairbanks. And how do they form? This is one of those charts that causes people's eyes to glaze over. The take-home message is, stuff over here, naturally made, don't worry about it, it doesn't get in your lungs. This stuff here, smaller, mostly combustion related. What happens? You burn something, you get hot vapor, it condenses, makes particles, they hit each other, they bounce together, they stick. Imagine taking a bunch of ping pong balls, coating them in honey, and throwing them together. What are you going to get? You're going to get a big clump of messy ping pong balls. But that's what particles are doing. They're ping-ponging around, they hit each other, they stick, they get bigger. And here, the main way they get removed is they get washed out of the atmosphere. Drops form on them, and they rain out. If you happen to be near Augustine volcano a couple of years ago when it erupted, it was a beautiful snowfall. Everything looked perfect and white until you melted the snow. And then the water looked brown. It's because the snow was forming on the ash particles. So, formation, mostly the small particles are formed by human activities, the larger ones by natural processes. What are the impacts of PM2.5? Well, all you've heard so far really is the health impact in terms of the news. We also have visibility degradation. For those of you who've been up at the university, this is standing outside of the Geophysical Institute looking towards the museum. We're kind of missing the museum in that shot. Visibility degradation. Acid rain, these are the same particles that contain sulfate and nitrate that form acid rain. Climate, they reflect light back to space, or they can form clouds that help trap air. And pollutant or nutrient deposition. If I've got mercury in the air, deposits to a snowpack, usually it's a deposition from an aerosol. And the reason we have the PM2 standard that all of us are concerned about is human health effects. Let's give you some extreme examples that were tip-offs that maybe particulate matter might be bad for human health. First one, the London fog. 1952, 4 days, 8,000 people, 12,000 people died, 4,000 immediately, 8,000 delayed. All right, that might be a good tip-off that aerosols are bad. Donora, Pennsylvania, here's a US case. 1948, you have half the residents being sick and 18 dying immediately, 50 dying later. So it's a case where they were able to correlate the fact that they had particles in the air and people going to the hospital and dying. But what we found recently, and this is new, 1990s, not that long ago, was when they really first started correlating the fact that if you had small increases in particulate matter in a community, people showed adverse health effects. Who was the most impacted? Elderly, children, people who are already respiratorily, compromised. Why are children in this list? They breathe faster, they have smaller lungs, their lungs and hearts aren't as developed, particulate matter can have a bigger impact on them. The elderly, their lungs often are more compromised, they've already had a lot of insult over their lives, it doesn't take as much to cause an adverse effect. And of course, people who are already sick, you add another insult and you've got a problem. However, as most of us know from summer, you can be in perfectly good health and miserable due to air pollution. And a lot of it is the fact that air pollution really does impact everybody. Why? Because we're breathing these into our lungs. So you go ahead and you breathe it in. Now, if it can make the turn, particle falling, comes into your mouth, we call it PM10. If it comes and can make it up into your nose, really it's PM2.5. So you've got a different cut point here. But when it makes that nose turn, what happens? Well, a lot of it impacts out in here. We're not so worried about that. You blow your nose, you get rid of a lot of it, you end up swallowing it, it goes down through your gastrointestinal tract. Some of it actually goes a little bit deeper. It can impact out the cilia in your lungs to now flush it out. You know, they are really good at clearing stuff. But a lot of it goes deep, and it gets stuck in the little tiny sacs in your lungs. That's where the major concern is, and we're concerned about particles that can get that deep. So what size particles do that? Well, this is one of those great curves. It says, okay, pulmonary, this means deep lung. If the particle is 0.05 microns, so this is one of those really, really tiny ones, you have basically a 60% chance it is going to stick in your lungs, in the deep lung. So if you happen to have lots of particles that are very, very small, which are of course caused by human activity for the most part, you're going to be looking at a fairly obvious respiratory effect because you're getting it deep and you're at a point where your lungs can't clear it well. So, what are the effects of when they get stuck in your lungs? Well, short-term effects, you have my favorite, premature death. How's that for an obvious endpoint? Basically, if you're already compromised, you just get pushed that last little bit over the edge and you die sooner. Non-fatal heart attacks. Okay, we're talking about breathing stuff into the lungs. Why is heart attack an effect? Well, it's a fact that you breathe it into your lungs and the stuff can cross the lung barrier into your bloodstream because these particles are really tiny, and then they can have an adverse impact in terms of hardening of the arteries and other things, which is also why you have the non-fatal heart attacks. Increased hospital admissions, cardiopulmonary disorders of all sorts, including decreased lung function, irregular heartbeats, increased asthma. These are all short-term effects. What happens if you're exposed for a long time? Then you get the chronic effects. So we're talking about an extended period at elevated levels, which would be Los Angeles, where they violate on a regular basis. So what you have, reduced lung function over time. You just can't breathe as well. Your lungs are constantly being insulted. And premature death, again, if you're already respiratorily compromised, you keep shoving stuff in, it's not going to be good. And development of chronic respiratory disease in children. So when you've got asthma and other things, you always have the concern of, is it the particulate matter in the air that is helping affect my child? So this evidence started coming out in the 90s, and the EPA said, we can't ignore this. So they put in a new standard, PM2.5 standard. And it's referred to as the National Ambient Air Quality Standard for Fine Particulates, PM2.5. New standards were for an annual average of 15 micrograms per cubic meter. Okay, just like a microgram is 1 × 10⁻⁶ grams. If you take a paper clip and you cut it into 1,000,000 different pieces, that one piece would be approximately 1 microgram per cubic meter if you put it in a 1 meter wide piece of air. So we're not talking about a lot of mass here. And the 24-hour average standard is 65 micrograms per cubic meter. These standards were designed specifically to protect people from particulate matter. Now, more data started coming out. Remember, I told you in the early 90s is when they first identified this. A lot of studies got done, the science got better, and they said, we've got a problem. The standard's not tight enough. So they tightened it to 35 micrograms per cubic meter for the 24-hour average. Warning, guys, we hear through the grapevines, it may go down further. They also may mess with the annual average, which we had been tap dancing right below. So things could get more exciting here. Why did they tighten the standard? Because the science said you're not protecting enough people. So what are the benefits we hear about? Well, this is the list that the EPA gives. Where you start seeing impressive numbers is 2 million days when people must restrict their activities due to particle-related symptoms. That's a lot of people days. So in terms of things, 2,500 premature deaths in people with heart or lung disease, etc. This is per year. So they're talking about a lot of impact. How expensive is this? Well, they're estimating that we'll save $9 billion to $75 billion, got a little bit of a range there, for spending $6 billion each year to bring us into compliance. All right, that's quite a bit of money, and it has to do with the health costs associated with the people being in there, people dying, people being respiratorily compromised. It's a lot of money. So they said that works pretty well, but the question is, who benefits and where? Now, Fairbanks, we've been good kids, we've been making the measurements, and under the old standard, the 1997 standard, we were in compliance. Okay, that's good. New standard, not so good. We are now seriously out of compliance. So, when does it happen? It happens in winter, and we'll get into why in just a moment. But what you see is we average, somewhere between 10 and 30 days per year where we've exceeded this. The past year was 40-something. So far this year, I think we're at 34. So, not so good. Good news is we're not alone. All these black dots you see, with the exception of Juneau, they managed to squeeze by controlling wood smoke. Basically, everybody who is a black dot got thrown out of compliance by the tightening of the standard. And you'll notice that a lot of people were already out, the red areas. These are the areas you expect, the Ohio River Valley where there are power plants, it's Central Valley, California, which will never come into compliance due to natural levels, and a lot of places that happen to have inversions, and they're at the bottom of valleys, which would be like Fairbanks. When do we violate? Well, I like this one because it's color-coded. Red would be summer, blue would be winter, and what would we see? We see great big forest fire smokes every summer. We see a lot of over the limit violations in winter. Okay, we've got two different processes occurring here, and it shows up, back one, very clearly in this graph. This is the past year. This data was as of Sunday. And what we had was, a little bit in March, we had nothing in spring, we had nothing in fall. We had our nice wildfire smoke events. Now, nice thing about wildfire smoke, it's called a natural hazard. Translation, we didn't do anything to cause it, we can't stop it, therefore we are not held responsible for cleaning it up. If we had to try to clean up every single fire that hit Alaska, we don't have a budget big enough, although we all would have gainful employment forever. Now, here in winter, we see it's getting colder, people are heating, guess what? We start violating. And as you'll notice, this is 15 days in December that we were above that 35 microgram per cubic meter limit. All right, why do we violate during winter? Cold temperatures. We all live in Fairbanks, we know it's cold. What do you have to do when it's cold? You heat. You warm your cars up. All these things that do produce emissions. And the other problem, of course, is we have the wonderful Fairbanks inversion, where the air is very stable, and those of you who got to go play with the dry ice, you can feel the temperature difference. All those of us who live outside of town and drive down into the valley and watch your temperature gauge on your car do what? Drop as you head into the valley. So emissions that happen to be near the surface get trapped near the surface by that cold air. This is one of my wonderful "Where is Fairbanks" shots. Fairbanks is there. You can see the airport tower, but it's a case where we have the inversion. The ice fog does a nice job of delineating where the top of the inversion is. So how does the inversion form? Well, we're in the middle of winter. The ground has a certain amount of warmth. It's radiating it to space, which means the ground's cooling. Well, as the ground cools, the air next to it, in contact with it, also cools. And we know from ponds and cold water, etc., cold air does what? Sinks to the bottom of the valley, and it takes the emissions on the sides of the valley down with it. So now we have a cold pool at the bottom of the valley where we're driving around, we're heating our houses, all those other things. So we end up with a bunch of emissions trapped down here with the cold air. Now the cold air doesn't want to rise because it's got warm air above it. Warm air rises, right? And we have no heating coming in at the ground, so there's nothing to cause this to overturn. So unless we get a storm system or something through, it sits. We all know this. We all know those ice fog days. So what happens? Well, above and below the inversion, we have very different aerosols. I did an experiment a couple years ago where a friend of mine who lives down near the fairgrounds had a sampler at his house. I live out Chino Hot Springs Road. I had a sampler at my house. I had beautiful, light reddish-brown bands that were wood smoke. He had big black bands that were primarily heating. Very different above and below the inversion. He was below, I was above. The other thing is we have very low concentrations. If you're above the inversion, if you're below, you see the violation limits. So we have less anthropogenic influence above the inversion, and that the inversion's trapping local sources. All right, this is one of those classic air quality graphs where Alaska's off of Mexico. And actually, this is an improvement. Before 2001, we had one site in Alaska. This is the National Park Service network, and we were pristine. So we had one site for the whole state. That was Denali National Park, which the good news is we have a really long record, so we can actually look at what's going on. But the key thing is here, this data was 2000 through 2004. What happened in 2004? The fires happened in 2004, and when they're calculating the annual average at the park, they do not throw out the fires because they're not looking for a natural hazard. They're not trying to determine violation. Even then, look at the concentration. The concentration is between 3.6 and 4.8 micrograms per cubic meter. This is our background air. So when we have a case where under the inversion, we happen to be 80 micrograms per cubic meter, our background air, the truth is, if you don't have a bad fire year, is around 1.4 micrograms per cubic meter. So the background air is very clean. What we're dealing with is local. And how dramatic is this? This is from one of the Cold Climate Housing Research Center reports. I love this report. It is very useful. And what it's showing is, if I have the same thing emitting over the same time period, and I have a 10-meter high inversion and a 100-meter high inversion, what does that do to my concentration? If I happen to have a very high inversion, I've got more area for the emissions to mix through, my concentrations are much lower. If I have a very tight inversion, I end up with a very high concentration near the ground. So the inversion makes a humongous difference in terms of what we see. What are the sources we're dealing with? This is what you call a misleading graph. You see here a lot of wood smoke, but you see all this vehicle stuff. Well, these are done by chemical mass balance, and it's only as good as your source profiles. And this particular set, which was done by a student of mine, there was no home heating oil-fired furnace signature. And we all know that heating oil happens to be what? Diesel, right? So what is the diesel going to look like? It's going to look like a vehicle emission. It's not. It actually is home heating. in addition to the vehicle. You can't separate the two. But the key thing is, during the year, we end up being much cleaner in summer, away from fires, and in winter, we have this huge wood smoke component and a lot of home heating. The other really cool thing about this is look at the power plant signatures. During winter, there's almost no contribution from the power plants. Those of you who drive in this East and look at the power plants, why is that? It's because they emit above the inversion. It requires very specific meteorological conditions for them to mix down. So normally we don't see that much power plant emission at ground level. Now, all the analysis so far says the key primary source for PM2.5 in Fairbanks is home heating. It is wood, it is oil, it is coal. And it also is heating commercial buildings. That's a little less so than the rest. Recent analyses are suggesting approximately 63% of Fairbanks PM2.5 and 80% of North Pole 2.5 is due to wood smoke. That is a huge number. And to give you an idea, if you happen to have 80 micrograms per cubic meter of PM2.5, which was our worst case this year so far, and 63% of it happened to be wood smoke, if you got rid of all of the wood smoke, you would be in compliance. So it's that big an impact. These sources, though, are tough to manage. Why? They're what we call area sources. We like power plants as an air quality person. Why? I need to put one set of scrubbers on one source, and the problem is taken care of. Anytime we deal with an area source, we're dealing with lots of different houses, we're dealing with people's cars, you're dealing with something where it's going to take a lot of different measures in order to work. It makes it a much tougher problem. And one of the nice things is that we do have a lot of people here who are studying it, reaffirm what we've seen using different methods. So the graph I showed you before is what we call source apportionment. When you do actual modeling, using more sophisticated models, you get the same result. Power plants, not so much in terms of the influence. We use carbon-14 dating to try to determine if the carbon is fresh or if it's a fossil fuel. It all says wood smoke. And this is one of those graphs that makes my heart sing. Wood-fired hydronic heater, coal-fired, non-certified wood stove, oil-fired, certified wood stove, pellet masonry, natural gas. This is an emission in pounds per household. And what it tells you is what are going to be your clean burning sources of heat and what are not. I think it's pretty apparent which ones are not. That would be your hydronic heater and your coal-fired. And what happens here is that it does not take many of those in order to have a significant impact. We don't have that many hydronic heaters in the area, although I'm willing to bet almost everybody can tell you where they are. Because why? Go by Wood River Skill, what do you see? You see a miasma right about nose height. And that tells you that there's a hydronic heater nearby. A friend of mine who mushes said, you know, wood stove, smell quarter of a mile away. Hydronic heater, you can smell a mile away. But we don't have many of them, but they produce a lot of tons per year because they produce so much per one. Oil-fired comes up significantly because although oil-fired is fairly clean, a lot of us use it. I mean, I'm guilty of using oil-fired. And what you end up with is that when you take that little contribution over everybody, it adds up. Wood heaters, this is everybody else, is another case where if you add it all together, the levels go up. Coal-fired, we don't have many people who do it. And then this is the holy grail of clean air, is the natural gas. We'd love to have natural gas because it burns very, very cleanly. Now, winter 2009-2010, which we are in the middle of, as Jim Connor so nicely put it, we had more exceedances by the end of December than we had all of last year. Okay, that's kind of eye-opening. And as of last Sunday, we had 34 exceedances. Why have the violations been going up? Well, we've got a bunch of probable culprits. We happen to have a population growth. We got a bunch of people back from the theater. We have an increase in use of wood stoves and other heating devices because the economy has been bad, so people have gone from heating with oil to heating with wood. And they're not as familiar with heating as wood. So a lot of people have been using unseasoned wood. They haven't had their wood built up for years, so they are burning stuff that is wet and isn't very efficient at burning. And we have an increased use in coal. Some of this is a case where people who weren't familiar with burning wood burned the unseasoned wood, which didn't burn very well, so they had to burn more of it, so they ran out of wood and switched to coal. So all of this brought up to the fact that we were emitting more of the things that we were concerned about. Now, this is going to be technical geek speak for a moment, so phase out. If I happen to have a particle of this particular size, so from 0.02 microns in diameter to 2.5, remember our standard is 2.5 and smaller, here's how many particles I can have in a cubic centimeter. So think small ice cube. And have a mass of 10 micrograms per cubic meter. So if I've got a mass of 10 micrograms per cubic meter, and a meter is like 3 by 3 by 3 in terms of feet, I can have 1.2 of these particles, 2.5 microns, in that particular mass. I can have a heck of a lot more of the smaller particles. All those of you who are students who are taking geometry, difference between a radius and the volume of a sphere goes as r cubed. So it goes up rather quickly. So it doesn't take many large particles to give you 10 micrograms per cubic meter. The standard we're dealing with is mass-based. So what do you want to do? Which particles do you want to take out in order to meet your standard? You want to take out the big heavy ones. Makes sense, right? So you want the smaller particles because you can get more of them before you get enough mass to worry about. So how do you get smaller particles? The answer is you burn at higher temperatures. So when you do high temperature combustion, and it could be wood, coal, oil, diesel, whatever, you end up with a lot of smaller particles where you've gotten rid of most of the water and you end up with particles that are almost pure carbon with almost no hydrogen on them. If you burn at a lower temperature combustion, think unseasoned wood, you have a case where it's going to be damper, you're going to have more water vapor still in there, you're going to have more hydrogens attached to your carbon, and you end up with a bigger particle. So if we want to bring the particle size down, we need to burn at higher temperatures. If we apply it to Fairbanks, if you're running a nice EPA-certified wood stove, you're using wonderful seasoned wood, you're burning high temperature, you do not let it smolder in between, you're not going to be producing much mass. If you're running a hydronic heater, you shove in wood for 3 days, it burns hot, then it smolders. So you're doing incomplete combustion, you're producing bigger particles, and then it flames up and then you let it smolder. You're going to produce a lot more in terms of particulate matter. That's why we like the seasoned wood, dry please, and we like the EPA-certified stoves, especially with, nice secondary catalytic converter type behavior, extra combustion chambers. But it's a case where how you do the burning is going to change what your emissions look like. And when we look at vehicles, we see smaller particles. Why? Cars run at high temperature. So you end up with smaller particles. If you're in an area with a lot of wood smoke, the particle size gets bigger. And the trade-off. This is one that you don't hear much about. Recent studies have been showing that the smaller particles can be more toxic. Oh, great. So we're coming into compliance on the mass-based standard, but we may be causing a bigger health effect. So we've got a trade-off here. We have to meet the EPA standard, but we may be doing something in the long run that's a problem. Now, the thing that is encouraging here is that we're Fairbanks. We are a natural test laboratory. When we had the wildfires in 2004, we had a tremendous amount of very small particulate matter mass because the fires were burning what? They were burning hot. I mean, these fires were booking. They were really burning. And we had a lot of small particles. Did people die? Nope. Did we expect them to? Yes, we did. We expected that the particulate matter would go up, like it would in an industrial situation, and that 2 days later people would die. Didn't happen. Almost nobody used the clean air chambers. The Noel Wien Library in the hospital where they had respite centers. We were expecting people to flock in. Nice, quiet place to read a book. There was nobody there. And our asthmatics, they used the arbutal inhalers, or they were smart and self-evacuated if they thought there was going to be a problem. So what we had was a case where we had an exposure to a wood smoke we didn't end up with any problem. Then I talked to folks at the Lovelace Respiratory Research Institute in New Mexico. They said, well, we exposed rats, and we didn't see much effect from wood smoke either. It's like, okay, maybe we have a trend here. Then I talked to the Germans, who exposed graduate students. Difference between US science and European science. They treasure the rats more than the students. We liked our students. But it's a case where they weren't seeing the same health effect from the wood smoke as we did from the fossil fuels. So if our stuff is predominantly wood smoke, we may not have the same problem. But if we were going towards the smaller particles and we were in California, you're going to be concerned. And they're actually talking about a new standard called the ultrafine standard, where they're talking about particles on the order of 100 nanometers in diameter, so approximately 1/250th of the 2.5. And it's a case where it's designed to protect health, because they're dealing with combustion-related fossil fuel, very small particles that often have metals and other things. Our current status. Officially, according to the Federal Register, we are now nonattainment as of November 13th. So what does this mean to us? It means that the EPA is working with the Fairbanks North Star Borough and the Alaska and Department of Environmental Conservation to develop what's called a nonattainment plan, or you'll hear it as a state implementation plan, a SIP, which will show how we're going to come into compliance within their required timeline. So what's the timeline? All right. Here is when we are published. We have 30 days for it to become effective. Our SIP is due 3 years after the date of designation, which means by 2012, we have to tell EPA how we're going to come into compliance. We have 2 years after that to come into compliance. And if you can't do that, you beg and plead, and they give you an extra 5 years. So we're looking at 2019 to be in compliance for PM2.5. All right, one of the big questions is what happens if we don't comply? Everyone says, okay, you're talking about particulate matter, what happens if we don't comply? This is what they threaten us with. Now keep in mind, the real reason to do this is to make sure that we're protecting the health of the people in the borough. Make sure that we are not causing any problems. But here's the club. Loss of federal highway and transit funding. Loss of economic development opportunities. This is an important one. In terms of trying to construct a new facility, if your new facility is going to significantly contribute to PM2.5, they can say, no, you can't have it. That's a big one. If you want to bring in a whole new striker brigade, they can say, oh, nope, can increase the PM2.5, you can't have it. That's one of the concerns. Enhanced regulatory oversight, restrictive permitting requirements, mandatory emissions offsetting. Translation, if I'm going to put this over here, I've got to decrease the amount by over here so that I don't add anything new. So how do we comply? We determine what portions of the borough actually are out of compliance. We identify the impact of each PM2.5 species and try to say, okay, where can we make the cheapest cuts and get the biggest bang for our buck? And of course, let's use common sense, folks. I mean, that's fundamental. There may be best available technology that's the holy grail, but we're not there yet. Let's do stuff that's going to work now that works. New technology, this gets into the we'll see if it works or not type thing. And then, of course, if we end up with a natural gas pipeline and a lot of money so we can spread the infrastructure, we should be in good shape. This is the borough non-attainment area. Initially, EPA said the whole borough is non-attainment. People in Salcha were not amused. People at Chena Hot Springs Road were not amused. As it is, we argued, the borough and DEC argued successfully, that we were not, all out of compliance. It was just this one smaller area. And I happened to be inside the non-attainment boundary by about 100 yards. But notice who is not here. Eielson Air Force Base. What did they do? They went ahead and did the studies and said, look, the wind is going away from us. It's coming towards us. Basically, we aren't contributing to the problem. in Fairbanks. EPA said, okay, the wind's not going that direction, you can't be responsible, and brought them out. So what we want to do is really establish where the limits are and argue that, okay, this whole area happens to be downwind, they can't be contributing to the problem, and their concentrations are low, we should remove them. So that's an important first step. Look at what other states have done. Let's not recreate the wheel. There have been a fair number of states who've had inversions. I did my PhD work in Reno. How did we determine how bad the inversion was in Reno? Well, how far up the Hilton was it given on a given day? Oh, it's a one-story inversion. Ooh, that's bad. It's a three-story inversion. Oh, not so bad. So what you do is you go ahead and say, okay, Reno had an inversion. They had one of the same problems we did. How did they address it? And the answer is they put in burn bans. Of course, primary form of heating in Reno is not wood. So for them, it was a little bit easier. IM programs, don't shoot the messenger. I was actually amazed EPA let us lapse the IM program for carbon monoxide because cars that are running well and do not produce carbon monoxide don't produce as much particulate. If they're running poorly, they're going to produce more carbon monoxide, which we've allowed for, but they also produce more particulate. So I was very surprised that EPA let us do something which they know will increase the particulate matter. No burn days, wood stove replacement programs. This is something I think you're going to see. When you take a non-EPA certified wood stove and you turn it in with some incentive to get an EPA certified wood stove, it's going to save you money in the long run because you're burning more efficiently. You don't need as much wood. It will help all around. Changing fuel sources for heating. There's where your natural gas comes in. Home winterization programs, etc. So, what could this mean? Right here, this is a suggestion that we go ahead and ban all wood-burning devices that produce more than 7.5 grams per hour or more. If we did that, what you would see is we would go from this huge amount here to 117 tons per year. So you would be looking at a 51% reduction in terms of the wood heaters, and we're losing basically everything from the hydronic heaters. Why is that? It's because even when they're running at their best, they're running closer to 14 grams per hour. So it's a significant increase over the other things we see. I love this graph. This is the influence of a hydronic heater overlaid on downtown Fairbanks. What you see is it's basically a 200-meter diameter of effect area. So one hydronic heater is going to influence everybody in that area. Now, everybody put one in. And you'll see that pretty soon we can't see downtown. But it just gives you an idea of why we might want to go after some of these bigger emitters. They have a fairly large area of influence. So if we take out one of those, it's going to be better than taking out a whole bunch of different wood stoves. Of course, we want to do some combination, and I, of course, know that the people who put in hydronic heaters have a lot of money invested in them. So if we were going to do this, we would need to make it worth their while. Change our heating oil. Right now, what are we running? We're running high sulfur heating fuel. If we go ahead and decrease the amount of sulfur in the fuel, which we're already doing for diesel trucks, right? We're producing the low sulfur fuel. What you would do is you would be able to run a catalytic converter or something on your wood stove, not your wood stove, your oil stove, and you would be able to decrease the amount of what we call secondary formation, where sulfur dioxide gets emitted as a gas, hits the atmosphere, converts into a particle. We see a lot of that in Fairbanks due to the cold temperatures, etc. So we would decrease the amount we'd have from that component. So overall, what are we looking at here? The PM2.5 standard really is designed to protect human health. And we at the moment are violating that standard, and the standard looks like it's only going to get worse. So we have to work with coming up with solutions that work for us here in Fairbanks. And the good news is we've got a good team working on it. Between the borough and the state, and EPA Region 10 actually is amazingly flexible for EPA. And also with the university, we've got a bunch of good research scientists who are trying to figure out the problem. We've got a bunch of policy people who are trying to make it work and who live here. This is an important factor. How many people remember MTBE? Hands up. MTBE was for carbon monoxide, right? And they put it in Fairbanks, and what's the primary degradation method of MTBE? That would be thermal breakdown. Translation, it breaks down in heat. What are we missing in Fairbanks in winter? That would be heat. So things that they thought were going to help, because they hadn't been tested under conditions like we have, don't necessarily work. So we want people here making those decisions and coming up with what would work. So we have a bunch of people here who are really trying to come up with a solution to protect the health of the people here in Fairbanks. And so when you see them, don't shoot at them. They're really trying to help you. So with that, I'm going to say thank you all for coming, and I'm here for questions for really as long as you guys need me.